Welcome to today's video. My name is Abdulaziz Idris, your regular Math 102 tutor. In today's video, we are going to look at example 4, where we are asked to prove that for all positive integer n, 3 plus 8 plus 13 plus up to 5n minus 2 is equals to half n into 5n plus 1. Of course, the way to prove this is in two steps. And the proof is in two steps. We have the inductive step, we have the basis step, and then the inductive step. And for the inductive step, for the basis step, we prove that it is true for n equals to 1. But before then, the question we are given is the proposition for n, which is equals to 3 plus 8 plus 13 plus up to plus 5n minus 2, and then this is equals to half n into 5n plus 1. It is very important to rewrite the given equation. Now, we test, as the basis step, we test for p of 1. That is when n is equals to 1. If n is equals to 1, you substitute here and then substitute here. For n equals to 1, the left-hand side is equal to this one. So we have 5 times 1 minus 2. Of course, this is equals to 5 minus 2, which is equals to 3. And the right-hand side is equals to half of 1 as 1 times what we have here is 5 times 1 plus 1, because this is equals to half of 5 plus 1, 5 times 1 is 5, and then plus 1, which is equals to 6, and half of 6 is equals to 3. We can see here clearly that the left hand side is equals to 3 and the right hand side is equals to 3. So the formula or the equation is always true for n equals to 1. So we say p of 1 is always true. And now we move to the inductive step. Now we are through with the basis step. And the inductive step is to assume that we assume it is true for n equals to k. That is, we say p of k is true. And what is p of k? So p of k, that is when n is equals to k. We have 3 plus 8 plus 13 plus up to plus. Instead of n, we say 5k minus 2, which is equals to half of k into 5k plus 1. Now, we want to prove that it is true for all n, so we have to prove that it is true for n equals to k plus 1. So in this, for us to prove, we have to say we are going to prove, we shall prove that, since we have assumed this, so we are going to prove that p of k plus 1 is true. And what is p of k plus 1? Wherever you see k is equals to k plus 1, substitute in the above equation. We have 3 plus 8 plus 13 plus up to plus. Here is 5, so we have 5, but k is now k plus 1 because n is equals to k plus 1. Proving for, we are writing for k plus 1. So for k plus 1 and then minus 2. This is equals to half. Instead of k, we have k plus 1, and then 5 into k plus 1, and then plus this 1. And what is this? This is 3 plus 8 plus 13 plus up to plus. So we have 5 times k, we have 5k, of course, and then 5 times 1, we have 5. So 5 minus 2 is 3, so we have plus 3. This is equals to half of. So we have k plus 1, and then 5 times k, 5 times k is 5k, and then 5 times, so we have 5k 5 times 1 is 5, then plus 1 is 6, so plus 6. This is what we are going to prove. And to prove this, what do? We say, okay, let's look at the left-hand side, of the uh, uh, given equation, which is here. So, in the left-hand side, if you add k, for example, taken here, if n is equals to k plus 1, it means you are moving ahead. You are adding just one term on the left-hand side. And since it is an equation, adding one term on the left-hand side involves adding the same term on the right-hand side. And this is going to be, so we have 3 plus 8 plus 13 plus, because k is now equals to k plus 1, we're going to have 5k plus 3. We're adding one more term ahead because of k plus 1. So, and the term we are going to add is the term we are going to add, here, looking at this equation, here we have 5k minus 2. So we are adding one more term, so which is equals to what? 5k plus 3 when n is equals to k plus 1. Of course, we know how we did this. So this is equals to half of k into 5k plus 1, and then plus, because we have added it as a term here, so we have 5k plus 3 here as a term. We're adding it. So concentrating on the right-hand side, so the right-hand side becomes, so we have 1 over 2 into 5, actually 5 into k into 5k plus 1, and then plus, because this half, the denominator divides only this term. So therefore, for it to be under the same, all the terms here, we have to multiply this by 2. So we have 2 into 5k plus 3. So under the same denominator now. And then we have 1 over 2. So it means into 5 times, we have 5k square, k times 5k square plus k, and then plus 2 times 5, 10k, plus 2 times 3, this is equals to 6. So what we have here is that we have all this term over 2. So we have 5k square, k plus 10k plus 11k plus 6. But to factorize this, it is going to be given by k plus 1 into 5k plus 6. And when you factorize this, we have k plus 1 into 5k plus 6 divided by 2. And if you look at this, it's the same thing as when you substitute n equals to k plus 1. So what we wanted to prove, this is it. We have proved it here. Since it is true for n equals to 1, p of 1 is true, and then we know also that p of k is true, we have assumed, and then we know p of k plus 1 is true. Hence, it is true for all positive integer. N, meaning that is p of n is true. That is the principle of mathematical induction. Thank you for watching.